Hi everyone, welcome back to Coding and Analysis. And in this video, I'm going to cover the R-squared score and the MAE numbers. And then going to look to the CSV file from the random forest regressor results and just look at the different results of them. So the R-squared score is going to measure how well the model's predictions match the real values. So 1 is a perfect score, and 0 means the model performs no better than just predicting the mean. And then the MAE gives the average difference between the actual and predicted health grades, so lower is better. So as we saw in the previous video, all these positions they scored pretty low MAE, which was good. That was a positive. So when we start with this metrics, what we're going to do is, so we start off with the empty Python list, and then we're just going to do then all predictions. We're going to do the testing and the training combined. As we saw in the previous video, all predictions is the concatenated versions of the running back predictions, wide receiver and tight end predictions, and quarterback predictions rounded to 0. So then we start off with that, and then we go into this for loop for the all predictions and filtering on the fantasy position of the players. And then we're importing the R-squared score and the mean absolute error, or MAE, up here. So we got the R-squared score and the mean absolute error from sklearn.metrics, importing these classes. So you can see here, for us to analyze to get the score and the numbers right here, we have to get the actual health grade and the predicted health grade. So this is the results of the machine learning model, and this is the actual results that we calculated in the data set. And then we're going to append the empty Python list and create a dictionary of data and have the position, and then the R-squared score rounded to 3 and the MAE score rounded to 2. And then we do the loop, and then position metrics becomes a list of dictionaries, which is then converted to this data frame right here. We're going to call it position underscore metrics underscore df. Create the data frame, and then we're printing out the results. And this is for the combined testing and training, so it's going to be a really good score, close to 1. So yeah, it scored really well, and the MAE had very low numbers, so that was really good. But what if we wanted just to look at the testing data? So instead of doing all predictions, we're going to start off with the empty Python list, and we can just say we want to do test underscore only, and that's going to equal the test this data split up here. So this is where we're getting that information. And then do the for loop again, and fantasy positions we're filtering on, and we're getting the R-squared score again with actual health grades and the predicted health grades, and appending the this data becomes a dictionary into the list. So it becomes a list of dictionaries, which then is converted to the data frame, just like we did before. We're printing it out. And we can see here the numbers are a little bit lower because this is the test data, but not too far off for the running backs and wide receivers and tight ends. The quarterback, the R-squared score is really off. So let's go look at the QB results and see what could be the issue there. But then the MAE numbers are still very low. So it's only 3.6 points off, so that's not bad at all. So let's go look at the results up here, and this is the running backs first. So like the R-square and the MAE results show nothing too far off. And the see, Christian McCaffrey, health grade is 71. Our predicted health grade is 67, so that's pretty reasonable. And we have Bijan Robinson, 100, good score. And then we have some of the rookies coming in with O'Marion Hampton, 100, and Jonathan Taylor. So our predicted health grade is a little bit higher at 83. And we can see here that Ty Chandler, our health grade was 90 and the predicted health grade is 76. I think that is the fact that he hasn't played too many games is factoring into the score, even though he's considered healthy. So that's why it's showing 76. So we'll go look at the feature importance for the running backs again after this. So then we go into the wide receivers and tight ends, and everything looks pretty close. Nothing too far off. We have let's see, Keon Coleman, 86, 90, just a tiny little bit off. Brandon Ayuk, 75 and 76. Not too bad. Tank Dell, 76, 77. You know, that is, he probably will miss the upcoming season, so I might have to factor that into the upcoming models. And then let's look at the testing for the wide receivers, tight ends. Marquise Brown is predicted 62. Our health grade, my health grade had a 53. So it's just fun to look at this data and see the different differences of the model and the actual predicted health grade, the actual health grade. So we have Kyle Pitts with the health grade of 100 and the predicted health grade is 88. So that's a little bit lower than the 100. And then when we go to the quarterbacks, let's go look at the test data to see. You can see here Dak Prescott, he's in the training, but our predicted health grade is 75, but the actual health grade is 71, so not too far off. And the test scores, they all look pretty good, pretty close. Not too bad except for Daniel Jones, which he has a 66 predicted health grade, and his actual health grade was 82. So I think the reason for that is, we go back to the feature importance. For the quarterbacks, they were taking the 2020 health status as 52%. He was actually hurt during 2023 for, I think he only played 10 games, so he was hurt a lot. So I think that's factoring, that's why it's helping and giving him close to a 66, the model is. So if you took that one out for Daniel Jones, the R-squared score for the testing data would be close to the wide receivers and the running backs. So it'd probably be close to be 8 or 9 if we took the Daniel Jones out. So let's look at the running backs. So the health status, average season in games. So probably, Ty Johnson, his average season in games was lower, so that's probably why the model was giving him a lower score. So it's just fun to look at the different data and see what the models come up with. And in the next video, I'm going to chart all this information with the Seaborn and Matplotlib. So hope to see y'all in the next video. And always remember to never stop coding. And thanks for watching. Bye.